This is review for conceptual physics. We're going to call this one Day 1, which is reviewing what we learned in the first 6 weeks, which was units and kinematics. Kinematics is the study of motion, so how fast it moves, how fast it accelerates, that type of thing. We'll start with conversion. So you need to be able to convert between different types of units, especially in metric. So you need to know that 100 centimeters is the same as 1 meter. So if I gave you 23 meters, you need to know you need to move the decimal 2 places, right? So we started with 23 with the decimal here, and we know we have to move it 2 places to turn it into meters. With kilograms to grams, we know that 1 kilogram is equal to 1,000 grams. And so we know that if we start this time with 23, we have to move it the other way because it's getting to be a smaller number, so we move it 3 places, and that's where we get the 0.023 kilograms. 1 kilogram is equal to 10 newtons, so you should be able to convert anything from newtons to kilograms and kilograms to newtons. So if I tell you that it's 5 newtons, you would tell me that's 0.5 kilograms, and if I told you it was 3 kilograms, you would tell me it's 30 newtons. So you just know it's a factor of 10 going either way. Any other conversions I will give you. For example, let's say you needed to convert feet to inches. I know that one's easy, but let's just do it with the box method. So let's say I told you that you had 20 inches, but you wanted to convert it to feet. You know that there are 12 inches in 1 foot, so you put the inches on the bottom so it cancels. So that means you would take 20 and you would divide it by 12. So you'd pull out your calculator and you would go 20 divided by 12. Oops, trying. 20 divided by 12, which is 1.67. 1.67 feet. So you should be able to do any kind of conversions. I'll always give you the conversion factor if you need it, but these ones you should be able to do on your own without conversion factors. Equations. These are all the equations that you should know for kinematics. They should be on your equation sheet. Double check that they are. We have V is equal to D over T. Now notice that that says average speed, right? Average speed. So normally to denote average, we put AVG, or you can put a line. Let's make that line a solid line. A line over the top, right? So V like this is equal to V average. You can write it either way. But that's your average speed. A is equal to delta V over T. So remember that delta V is a change in speed. And so it's always equal to VF minus VI. Right? So you subtract them to be able to figure out what they are. And those VIs and VFs are instantaneous speeds at that point in time. So don't confuse VI with, or VF with V average, right? So it says the car accelerated for 5 seconds to a speed of 20 meters per second. Well, it said it accelerated, so it started at some other speed, and then accelerated to 20 meters per second. So 20 meters per second is going to be VF, not V average. Then we have VF, right, which can be equal to AT, which basically comes from A equals delta V over T, right? Because if A is equal to VF minus VI over T, sorry, I got a little smudgy there, is equal, looks terrible, let's try again, is equal to VF minus VI over T. If we start at rest, which we do 90% of the time, we can cross off the VI, make that 0, and so you can see that this then becomes AT equals VF, which is where that equation comes from. Now, if it's in free fall, A becomes G, so now you just end up with VF equals GT. So that's where that equation comes from. That's only if it's in free fall though, right? So you have to be in free fall to use G. And then we have D equals 1/2 AT squared. And remember, we figured that one out from the man falling, and we said his average speed, so you divide it by 2, right? This divided by 2 part, right? This 1/2 part, that is because you had to find his average speed. So you took the initial you took the final plus the initial divided by 2. And then in order to figure out that speed, you had to multiply it times gt, but then you had to multiply by t again to get vf. Anyways, it comes out to d equals 1/2 at squared. If you're in free fall, right, if you're in free fall, you can do 1/2 gt squared. But it's the same equation, right? Now, the last equation we didn't put on your equation sheet till near the end. We used it for our engineering task, and that was vf squared equals 2ad plus vi squared. Because we needed to figure out how fast or how far it would go at a certain speed. And then normally either VI or VF is 0, and so you just end up with V squared equals 2AD, right? So lots of times if we're using this equation, we just have V squared equals 2AD. All right? So concepts for when you're going in a straight line motion. Speed has no direction. But velocity does. So if you move in a straight line, velocity and speed are the same. So if I keep going straight, I don't care if it's speed or velocity, everything's the same. It doesn't matter. But as soon as I turn right, I go in a circle, I go up, I go down, I change directions. Now there's a difference between speed and velocity. My average velocity or average speed is the middle velocity. And so you can use either equation VF plus VI over 2, right? Because if you add up two numbers, right, that's VF plus VI over 2. It looks a little funny here, right? But that's this equation, right? So you can do VF plus VI over 2 because that's how you find average. Or remember, this equation here is V average. So you can do V average equals D over T. It's the same thing. So that means I could set this equal to D over T, and I would have an equation. Acceleration is the change in velocity, not speed per time, which means you can, to be able to accelerate, you can speed up, slow down, or change directions. So anytime you turn, you are accelerating, you feel that acceleration, but you don't have to speed up, right? You can just go in a circle or turn. Positive or negative, when you see the signs like negative 2 meters per second, that doesn't mean that going at negative 2 meters per second is going fast or slower than positive 2 meters per second. It just means it's going the opposite direction. So this way might be positive and this way might be negative. Right? So if it says negative 2 meters per second, that means the velocity is going like that. If it says 2 meters per second, then the velocity is going like that. But it's the same size, same thing. Everything's the same about it. Concepts for free fall. The big thing you have to remember if you're in free fall is that the only force acting on it is gravity. And that means that all objects fall at the same rate if they're in free fall, which is negative 10 meters per second squared, which we call G, right? So negative 10 meters per second squared is G. Objects increase their speed by 10 meters per second every second. That's what 10 meters per second squared. So if I start at 0, right, and I fall for 1 second, that means I'm now moving at 10 meters per second, assuming I started at 0, right? If I started up here and I started at 5 meters per second, though, after 1 second, I would increase my speed by 10, so now I'd be falling at 15 meters per second. So I know every second I add a 10. If you go up, if you go the other direction, right, if I was moving at 25 meters per second and I was throwing the object up, so whatever it was, and it goes up here, then it's losing, right, after 1 second, it's losing 10 meters per second, so now it's going at 15 meters per second. Objects' distance increases proportionally to the square of the time, so it falls further and further each second. So if we erase this so I have some space over here. So if something is falling and it starts here, after 1 second it would be here, after 2 seconds it would be further, after 3 seconds it would be further because it falls further and further and further. So we know it's 1/2 gt squared and half a g is 5. So this distance is going to be equal to 5 times 1 squared, which is 5 meters. And then this one here is going to be d is equal to 5 times 2 squared. Well, 2 squared is 4. 4 times 5 is 20 meters. And then after 3 seconds, d is going to be equal to 5, because half a 10, times 3 squared. So 5 times 9 is 45. So you should be able to kind of predict how far something's going to fall based on the fact that it's free falling. And remember that the letter G is magnitude. So when I say GT or 1/2 GT squared, you don't put the negative in, right? No negative when you plug these in. That just means it's falling down anyways, but you're just using the number when you use it. Okay, let's do a couple sample problems. And so an object is thrown up into the air, sorry, at a speed of, ooh, that's a typo. You guys can fix it, right? It's supposed to say of 45 meters per second. How long does it take to get to the top? Well, we're going to do concepts for this one, right? We know it loses 10 meters per second every second. So how many 10s are in 45? Oh, I go 45. How many 10s are in 45? Oh, easy. 4.5. So it's going to take 4.5 seconds to get to the top. We could do it in 5 steps, but let's do the next one in 5 steps. So this one's a nice one. That first one's a nice one to do with concepts. So the second one, an object is dropped from a cliff. After 3 seconds, how fast is it falling? All right, so let's do this in 5 steps to practice our 5 steps. So in my given, I know t equals 3 seconds. I know that it's dropped, so it's free falling. So that means that g is equal to 10 meters per second squared. If I really wanted to, I could say VI is 0, but I don't know if I need it, but I just know it's dropped. How fast is it falling? So VF equals question mark. And so I said, oh, VGT, oh, VF equals G times T. It's already solved. And so VF is equal to 10 meters per second squared times 3 seconds, which is 30 meters per second. Again, we could have done logic, and we could have said, oh, well, it falls for 3 seconds. Every second, it gains 10 meters per second, so it should just be 3 times 10, which is 30. But you need to be able to do it both ways. You need to use logic, and you need to be able to do it with 5 steps so you can show your work and explain it to somebody else. Then the other thing that I wanted to make sure I put in the review is you need to remember what your engineering task was for each of these concepts. So for this engineering task, remember it was texting and driving. And we had to figure out the stopping distance of the car, and we know it depended on your reaction time, the initial velocity of the car, and the deceleration of the car. So remember, we found your reaction time, you dropped the ruler, and wherever you caught it, you got a distance, and then you did 1/2 GT squared. You solved for T, right? Because if D equals 1/2 GT squared, then T is equal to 2D over G square root, right? Because I have to multiply both sides by 2, because that gets rid of that. I have to divide both sides by G, and then I have to take the square root to get rid of the square root. So that's where we get this 2D over G square root. And then we made a graph, right? We made a graph of a VT graph. And remember, your car was going fast, and then it went slow, but it decelerated on the carpet. So it kind of went like this kind of thing, right? And because it stopped, but it decelerated at a constant rate, so that's why its slope was constant right here, right? That's a constant slope because it's a straight line. And the slope of this, so if you found this, oops, I tried to do it in a different color. If you found this slope, that was equal to your acceleration. It was negative because it was a negative slope. And then you found your maximum V, which would have been this point up here, V max, and that told you your maximum, which was equal to VI, what it started with. And then you did the VI squared is equal to 2AD to figure out what the stopping distance. Remember, we put it all into a spreadsheet, and we did the calculations, and you were all able to do it within 10% error, which was awesome. Well, most of you anyways. Good job.